And we are now live on YouTube as well. Just verifying that it is working real fast. Notify the Discord. If Discord decides to start up, that is. No, actually. Here we go. Discord has been notified. We can now start, actually start the stream. Alright, so what we're working on today is refactoring the way that I handle values on the compiler side of the scripting language. I'm not quite sure exactly how I'm gonna do it yet, so we're just gonna figure it out as we go. And don't pay any attention to this test. That's something for the the video that I wanted to have out yesterday, but you know, editing takes a while, so it will come out when it comes out. So, compiler or no. So remember, the thing that I wanted to change first was when I'm actually constructing when I'm actually like compiling the code, the way that I do it is by passing these values from each node, and those kind of just store like the register that value is in, any flags it might have, and just like values about the value. And I wanted to, instead of just having these be temporary return values, instead store them in the compiler context instead. That way we can actually keep track of, like, what if one is a constant expression and we want to simplify that? And just stuff like that to make it simpler. The other thing that I wanted to do was, right now we just store a value index. Instead I want to have a function where you call like create value index or something like that. And then that's when the value index is created. That way we don't run into issues like right now, the way that I'm handling like indexes of registers, since I just represent them with register, is I can actually reference a register that's one past the end of all created registers, and that will essentially create a new one, so I can like create one at a time implicitly. Though that's not really like that. Yeah, it's not the best way of going about it, but it's working for now. But the problem that, well, it's working for now. However, there is a problem. So the problem that it has after that is that, like, if you try to create them out of order, obviously it doesn't work. But for like the simple things I've done so far, it hasn't been a problem, but it's becoming more and more of a problem as we go on, so I want to refactor how I do that. Now just to figure out how I want to do it. Smart thing to do would be to figure out things, or at least a general direction, before you start streaming. However, I spent all my time trying to figure out how to get TikTok to work and not how to actually, like, how I'm actually going to do the coding stuff. So that's what we get to watch. Well, I have like a general idea of what I want to do, but not a general idea on how I do it. I know I want to start storing these in a vector in the compiler context, so I think I'm going to start there. Just like that. And then when we create new registers or constants, we can just return pointers to those. And then to solve my problem of register index, I'll just create a counter. Oh wait, I already have one. Oh my, how would I not? Yeah. Of course I already have one. Factor these as well. So instead of just directly storing the value index like this, what we're gonna do instead is we'll just have a value x, a function that just a constant function, and then instead of this, there's a little bit of collision between names. Do I call this the value index because it's the index of which value this is on the compiler side? Or do I go with the value index like I was before? Or do I rename this struct because value index isn't quite describing what it is? So what it is it's the bytecode, all the bytecode, all the value, it's all the information for a value that is, it's the serializable version that we store in the bytecode. So we could call it a honestly, it would just be value. You know what? we have all of this in its own namespace. We can just call it value, because that's what it is. So going back to here, because like this is the AOT value, ahead of time value, abstract object tree value, whatever you want to call it. Serialize the value here. That way it's actually like clear what it's doing. And then real fast, the other thing that, well, do I do it now or later? You know, I'm gonna get sidetracked and do it now. One of the other things that I wanted to do was, where is it? Come on, brain work, there it is. So I have all these like append code functions, but they're on the intermediate representation of the function. It's in this class itself, but I don't really think it should be here. Like read code, that makes sense. You know, we're reading the intermediate representation, but I don't know if the writing side of that should be here. It would make more sense for that to be on the compiler side, probably. Yeah. Actually, the reading makes more sense to go on the compiler side as well. I don't know. We'll come back to this later, but the main thing I wanted to do was we'll keep this template, but then these two, what I want to do is actually make them no longer templates and then force it to be a value, because I kept running into a problem where I kept accidentally doing passing in the AOT value instead of just the actually serializable value. So we're just not going to have these as structs. And for some reason my static assert that I put there to solve the problem didn't do a thing, never threw an error. So that's what we're going to do, is just quickly force this to only be values, and then anywhere where I was using other types, I can just use this other AOT. Wait, AOT node? This needs to be AOT value, not AOT node. That might have been why that might have been the problem. Was I doing the same thing here before? Well, no, because I changed it recently to something else, so I don't even know if that's the buggy code. But yeah, let's move this to the CPP file. So just wanted to get that out of the way real fast. We'll deal with the compiler errors for that later when we finally try to actually run all of this. But going back to here, make pointer for AOT value. So let's work on doing this again. So for new register, auto value equals Okay, that's not working. Have I not included? It'd be super weird if I hadn't. Okay. Oh, I have a different value struct that has been hanging out around here. What am I using this one for? This is another reason I'm doing this refactors, hopefully to get rid of this sort of stuff that's just not really making sense. Clean up the types that I'm using and all that sort of stuff. Oh right, I forgot. We want AOT value here. That actually is the value index from before. Forgetting how my own code works. In all fairness, it's been a couple of days because I've been, doing Thanksgiving and filming a video about the coding instead of actually doing the coding. And here's where we want to kind of take a look at this stuff. So this is the compile index, so we're going to value index is going to be equal to, actually if I'm just passing pointers to it, it doesn't really need to store its index, but we might need to use it later. Let's just over engineer it for now. Okay, so that looks like it was... Okay, so that's stored... Wait, we don't need that. Register index, storage type. We can fill all of this out. Over here in serialized value, which is where we want to do it. And then we're actually going to ask for a reference to the compiler context here. And then we only ever get the index, so... We can actually call it a value index now since it's... The data type itself is no longer called that. just gonna set it to max, and then so this is running an RTX sorry, okay, so CPU is a Ryzen 7000, dang it, let me just, I can't remember the actual, that's embarrassing, but yeah, the GPU is RTX 3090, there we go, I can remember it, let's see, there we go, just pull up system information. Okay. Ryzen 7 3700X, there we go. 32 gigabytes of RAM, all that good stuff. Oh, that's embarrassing. Can't remember my own computer's. Brain is in coding mode, apologies. And then, actually, store a storage type as well. So flags, compare type, VR compare, definition. Okay. We're just gonna store the storage type here. Then here we're just gonna assert that storage type is not value storage type null. Looks like I don't have that included. Switch on storage type. Leave for pointer. A reference pointer and so for a register and a pointer, this value type, or the, what was the value index? Index is going to be equal to If value index is equal to -1, oh right, this is a constant function. Oh well. We'll just have it not be a constant function. And then we'll also set the storage type to... Wait, we can just set it to the... storage type. And then... Okay, let me check how I handle different things. So I know for both pointers and registers, we want to do a register index, but I'm not sure about dereferenced or constants, how I handle those. So we're gonna check that. So for comparisons, we don't need anything. Well, for comparisons don't even get to compile. Well, they don't get to... They shouldn't ever be serialized. Actually, I can add that as an assert real fast. Just to make sure we don't accidentally do that. Okay, so for dereference and constants, how do we do dereference and constants? So for constant, we do a memory index. And I'm not sure about dereference pointers. So in the dereference node, well, we actually keep the same index. It's a okay. So that's what I need to do. We'll add. Hello, how's it going? That's not too fun. In here, we're just going to say is dereference pointers should really be the only ones with offsets. We'll just make sure that it's basically we only set that if it's a pointer. We'll just set this to value index like that, and storage type has already been set, and then we can just return value. And it's giving me that error, so I have kept value small enough that it fits inside a single register. That's nice. Going back to here. We don't need to do any of this stuff anymore. We just need to set the storage type, so set value storage type like that. Ooh, that's another assert I should do is just... Oh wait, I'm already doing it. So we can just do this without worrying. Was valued out get, and then values push back. Or even better, we can just go new value like that, and then only convert this into a unique pointer. We actually add it to the list. All right. Want to cast this to a value. Need to, instead of passing in references, we'll pass in pointers. And I think I was doing something different with this whole switch statement here. Because all this is basically just an assert that it is not null. So we're just gonna do that. Assert that storage type is not value storage type null, like that. We can just delete all that. All the cast value does is basically make sure that if this is the result of a comparison, that we convert it from being the result of a comparison. Because comparison results are stored in CPU flags instead of registers. We want to get that converted into a register. If we need it in one, that's all that function does. So then for a new constant, we don't need to worry about memory index, type, or that. So we just like that. And then I'm going to yoink these. That, fine, I'll do the auto formatting. Now for casting a temporary. Actually, I have a function for this now, don't I? So we're just gonna use that instead of just using the flags raw like that. If the value is temporary, we just return it back. Yeah, we're just gonna call this value. Like that. On to the next one. Okay, we do actually need to use flags. Well, actually, it's checking storage type, not flags. Right, it is a pointer now. Well, that's working. Let's just check what's going on up here. Ah. So we need to refactor this. Which actually works a lot better than the jank stuff I had going on there before. So for value node, we can just now if this value stuff changes, then it'll change on all of them. Though I probably do need to refactor this, even though I think I just refactored again yesterday. You know, you tell me to use make shared instead, but then when I convert it to that format, suddenly it doesn't work. And then in value node as well, when we generate bytecode for the value node. Actually, we don't need to store an initialized anymore. We can just store if value. Because we just make sure this is initialized to null pointer. It's like that. Yep, just like that. If value, then we can return value. And here we need to refactor this entire function. Every single instance. Oh, there we go, now it's working. We want this to be a value pointer refactor. Please don't break anything this time. It always breaks stuff. There we go. I'm just hoping that didn't break anything, because... Okay, that's not bringing up anything too bad, so... Shouldn't have. We'll just hope that it redo it on all of the... it did not. It's like, come on. Isn't there an easy way to refactor every single node? Wait a second, did I say up? No. Oh, you got... No, I didn't want to refactor that. Dang it. I'm stupid. The thing I actually wanted to refactor was this. Well, that took a lot less time for a lot more functions than just one. No problem. Thanks for hanging around as long as you did. You know what? I will just here. We'll add back in a template for an operand and then a value. It's like that just because I use it so many different times in so many different places. Then we'll just like that. There we go. That takes care of a bunch of those. Now for the dereference node. The dereference node is conundrum. I think I'm going to create a new function in the compiler context for that. So we have cast value, cast temp. We'll have a deref pointer one. So this one is AOT value. Have unsigned 16-bit integer for the offset that we want to dereference that with. And we will also have the value type. So now we'll have type def. Because that will fit in later when we'll have structs inside structs, if I ever get around to implementing that. Come on, you can create the function. When the IDE does not IDE. We'll just assert that this value storage type is in fact a pointer. Gotta assert that that value's been used at some point. Just to make sure. And then we will create a new value, so pointer what's new. a deref value, which is just a copy of the AOT value. And then we'll also assert that offset is equal to 0 or value def type is equal to value type object or struct. And then here what we're going to do is we're going to convert the storage type to, well, we can actually look at what we do here. So offset, storage type, and return type. Value storage type is dereferenced pointer. The is equal to type. Pointer offset is equal to offset. It's like that, and then what we'll do is same thing as we do for creating a new register. Compile index and yes. All right. Apparently the TikTok stream has been dead this entire time because my phone had an internet error, even though my router is in my closet. Anyway, I will return shortly. All right. actually working this time. I'm just gonna go with the TikTok stream. We'll actually continue to work and stream this time. You know, it would have been nice if that stream was working while I had viewers on the YouTube stream, so it actually looks like I interact with my viewers, even if I can't see that chat, and you know. Yeah. Thank you, TikTok, for working so well and making it so easy to go live. This was sarcasm. Also, I would not like to get chat messages from suspicious bots in my chat, if you don't mind, YouTube. Alright, where was I with this whole thing? I think I was dereferencing pointers, or I finished doing that. I think I finished doing that. So, visit function, value, new register, register local value. Okay. That's fixed now. Back to value nodes. Now when we dereference, all we have to do is turn this into a pointer and then dereference it. Just like that. And then I think most of what I'm going to be doing is just... Actually, we can just pop. That. There we go. That replaces most of them. So now we can actually deal with the stuff that is actually broken. Excuse me. Construct declaration of value. Here. Oh, okay. We'll just scope those. Go fast, and I'll have to go through and fix that now. But that fixes this problem, so. Oh, that's another great thing. I can return null pointer. It's amazing. Let's see, so for comparison node, the result is we'll just generate in here. That's null. We're setting a compare type. Storage type is equal to actually we don't need to do anything else except for worry about the fact that this is not scoped in any way. So this is a pointer leak, or not a pointer leak, it's a memory leak. Pointer leaking memory. So I guess we just have to add a thing here. Value pointer. We will create just a blank value thing. What the blank value will do is it will just return a default value without any of this set. So it's just that value. Rename that because I copied and pasted from the wrong place. That was not the best place to copy and paste from. Copy and paste from. Let me just make sure that there's no other flags I need to set. All right. Okay, so the memory is now managed. Blank value, we just need to fill this. Hmm. Cool. So we're getting close to being ready to test this. Or not. Just one more file to refactor. So we need to refactor this to take a pointer instead. Alright, okay, we'll restore the other function. Actually, I could just manually define a append code. And for here, unsigned 16, because that's usually what we use for indexes. And then just easy, and then here, all those stop complaining. Keep wanting to say value type instead of node type. Same thing here. Sorry, kind of just spaced out for a moment because I realized something I need to make sure of before we run it for the first time. And that's to make sure that argument values actually do have their need to make sure that they do actually have their values initialized ahead of time instead of the first time that they're used. Otherwise, we're gonna have very fun problems. Alright. So I think this isn't compiler. No. Is it function? Why did you scroll? There we go. Using arguments. Then create values. We're just gonna say value dot value index is equal to register index. And we don't need to do that, it's just fun. 2 birds with 1 stone. So that will make sure that's initialized beforehand, and we won't have any issues there. Alright, bring on the compiler errors. There we go. Some more of the same. Value, no, node type, not it's not value, it's never value. Just gonna copy that for later because I'm guessing, yep. I thought I refactored this file. That's fine. Didn't take too long. From int to uint. Oh, that's just a warning. Okay. Script malloc diff. Oh, it's because I'm in release. Okay. Not debug. And we also need to bring that over to library tests, I believe. Yes. Oh. Here we go. How are we doing? Exception. From nowhere? That doesn't help me much. Oh, it's because I'm in release, that's why. Why am I debugging in release? That's dumb. Oh, now all the assertions are throwing errors. Because we were running in debug, we were running in release before and didn't have assertions. Value index. Oh, there it is. Yay. Bring me to the next error. Or not. It could just run. Oh. Cannot return nothing from non-void functions. Okay. Oh, it's a parsing error. That's what it is. All right. Time to break out the manual flushing of the console. So there we go. All right. Ooh, we're getting an error on the first one instead of the... Okay, so our problem is that the jump if equal isn't getting parsed correctly. Okay. Oh, what am I using for marks? Am I using... Mark indexes are... Okay, yep, they're 32-bit. So what's happening is that... Yep. So we're just gonna go here and create a 32-bit version of this function. All right. Same deal, and that should fix it. Do the tests now run? They do not. Okay, so the problem is... Well, yeah, exception, but... So return... Oh, okay. It's just that... Return value... Why would it... Why would it throw an error there? Fail with message. Console isn't showing a message. I mean, we can always try flushing the... Okay, still... Oh, is this the message? Just the... Exception! An exception was encountered. Very useful. So was there some sort of debug thing with saying, oh, you're returning a random value from this function that doesn't actually point to the real value? Because that'd be a very useful debug feature, but also, why would they have that debug feature? I'm just gonna try putting null pointer there and see if that fixes it. Okay. So the problem this time is that, okay. Script malloc difference, which is 0. For some reason. Actually, I can see why that would be the way that it is. Maybe. It's not working the way I want it to, though. Actually, no, wait. In this file, yes, I do want it to be that way. I think I accidentally, when I copy and pasted it earlier, broke it. So the problem that's happening here is that the value that's being passed in has not been initialized yet. It's not been used yet. So we need to trace this back to okay, so it's the first time deref is being called, which makes this pretty easy. Have to go here, and then okay, this is the first time objects are used, so we don't need to worry about this being triggered by any other tests. So there we go. We can just step through this. Okay. So register index is already at 1. Text to value. Context value. Neither the compile nor the value index are set. Well, actually, the value index is set. Okay. Which means that function worked. At least that one worked. Which means the next two will probably work as well. Yeah. Pointer. Value index, yep. Looks right. And then this one should be working as well. Yep. Which means this is the one that is the next contender. Okay, so this one has been created in advance as well, so it's an argument. To this function. What was I looking at again? Oh, right, the value. Value index 0, so it has been set. Okay, so that one's working as well. Yep. Pointer value index. Okay. So if we visit function, where's visit function? Program segment. Function. The current function being compiled is create struct. Okay, Which means this is like the one I would expect to fail. But it didn't. Okay, which one of these is going to cause the problem? I need a problem to fix. Alright, this is create struct still. Pointer, value index, yep, still 0. Okay, new. I'm just gonna keep going until we hit. Okay, test struct 2. So this is the one. It's the last one in the thing. So we have create struct, and then maybe it's mod struct. No, wait, that one's commented out. It couldn't do it, so it is test struct. Test script struct. So this is literally the last one that it could be. Oh. Interesting. Maybe. It might be interesting. We will see. And I think I know why it's causing it, now that I know it's that one. And the context. Or not. I could just not know. Okay. Pointer value. Okay, so that was the one that was broken. When I accidentally stepped over it instead of stepping into it. Actually, we can check value. This is AOT node of type value. I think actually, yeah, I know what's going on. So when we go to value nodes, I didn't look too closely at the value node generate bytecode. So if this value has not yet been accessed, it allocates a new thing. So if we value, well, that's when it should allocate the values right there. If this is so alloc, so this is a local struct. And this would be an external one, I think. Interesting. So it's actually really interesting. Value node, come on. Where was it? Oh, it's up here. It's in the same file. I was jumping around through all my shortcut keys, and all I had to do was scroll up. Okay. I never set stack reference ever. That might be the problem. Yeah, stack reference. But that should still... I can actually move this back. But like, that should still work, at least on the compiler side. It's on the actual linking side that would break normally. I would think, at least. Because we always call value that. Okay, let's step into it. Yeah, this is a value index. Index is 0 already. We just use that. And the next time it calls it. Huh. What is going on here? Because we should at least once call this, you know, if yeah, we have the reference that gets called, but then non-references never get called. Basically, the difference between these two is owning and non-owning pointer. Whereas stack ref is the... Actually, neither of them would be owning specifically, but it's like... This one's a pointer to a struct that's on the stack, whereas this one is to one that's been passed in through a function, whatever. Still don't understand why this isn't working quite right. So every time we initialize a new value, this should be called. Okay. Play the game of which function? Function context pointer. Function create struct. Okay. So this one works. I should have called that twice though, I would think. And to clarify this, or to make sure this is in fact, yeah, the function with test struct to test script struct. It's this one. I feel like value should have been called for these two as well. So I'm just gonna try to fix it the way that I'm guessing and not the way that I think is... Well, I don't understand what's going on. But we'll try. So... is it... yeah. Duration. Info. Register local value. Register local value. We'll just guess with this one. If type dot is ref, if this isn't a reference, and we're using this function instead of this function, I'm going to make the assumption that it is a stack. Is a stack value. Or we can actually just go into here because this is where is ref stack ref. Okay. So we could set that back out here. Actually, we could assign it all the way back out here. If type info, if this is not a reference, and type is equal to struct, then we want to set type dot, oh, type info. That's what I'm missing. Stack ref equal to true. Thinking about that, that won't do anything. So going back to the value nodes, if this is not a reference, it just returns. That might be the problem here. If this is not a reference, then we just return the value. In the place where I would usually return, where I would usually allocate structs, even the non-reference types, is right here. So what I need to do is put an and right here and say if this is it's not equal to value type struct, because if this is a struct, well, what is type again? It's a string. Okay. So we need to do res type. Like that. If this is not a reference, and it's just a struct. Okay, stack ref. So this isn't able to handle references to things other than structs at the moment, which is fine. We have checks in place for that. Will it work now? This is not a stack reference. Oh no, this is a stack reference. And which function is this? This is create struct. Okay, I think it's actually, this is something that wasn't working, that is now working. And then this one should go there, and then we should get one more. Or not. Oh yeah, right, because I have the thing where it copies over. So this is what I'm expecting it to do. This is good. And then this one should be, yep, there we go. And then it shouldn't get called again. It didn't. And instead we got a error when it tried to delete. So we're making progress. And I had this working before in a previous version, so this is all just smooth sailing from here. So error, expected equality is these values. Create struct A. One, which is false. Create struct. All right. Let's look at the bytecode. So for creating struct, we externally allocate a test struct 1. We move a 0, so we initialize this one to 0, this reference to a null pointer. We move the externally allocated struct into, or the allocated external struct, not externally allocated, into there. We then load the float constant. We move the float constant okay. Then we externally allocate that. That's not how that's supposed to work. So that's a bug right there, but not the one I need to worry about at the moment. Because it looks like it's treating this here as a reference instead of its own new thing. So I need to revisit that code there, because what it should do is copy the value over. So then after we move that, loads a constant, moves it into that one. So the bytecode looks fine, except for that one little thing there. This should be like a jank copy constructor instead of copying the pointer over. So I'm going to check. I'm gonna check the offsets because I think that's where we're most likely to have a problem. So to do that, I'm gonna add extra logging to the move statement. We'll just do moving a memory value to a memory value, and then we're going to add logging for memory offsets. So That's all the logging we should need to do. For that, I'm also going to do it for moving things into memory, just because... Actually, let's just do all of them right now. Okay, so now whenever we move memory values, we will actually get debug output for the offset if it's a pointer. Most memory values aren't going to be pointers, but yeah. That's kind of funny. There's copying and pasting. Alright. We don't need that debug statement there anymore. Alright. There we go. Dang it, the offsets look correct. Turn 0. Oh. See, for returning register 0, that means that we are returning the pointer to the stack and then telling it to delete the stack that has gone out of scope, which means that let's see, where is it? Return a value node. Honestly, these should be in the flow nodes, but you know. So the problem is that isStackReference isn't getting called. This should be the jank copy constructor thing I have going on doesn't work. It's just returning a pointer to the stack. All right. So I think, okay. Thinking. Let me look at my test code. Object. This should get set as a stack pointer, which I believe it would. Then we return output. So I'm just going to put a breakpoint there. Then we're going to test only that one. So we can skip over the first 3, I believe. So 0, 1, 2, and then this is the one that we want. Wait, 0, 1, 2. Okay. Let me just make sure this is the correct function. And I don't have to test struct 1, create struct. Okay, correct one. So click continue 3 times. Got it. First try. So let's see what the problematic value is. So it is a test struct 1, and this should be showing up as a stack pointer. Value. Is stack reference. Stack reference. Am I never setting it as a stack reference? That would cause it. So going over to value mode to generate bytecode. If this is not a stack reference, there. And then this is where this is what all of the refactors have been leading up to. It's the ability to say context value and then flags or AOT value stack reference. Oh wait, no, I already do. I already do that. Here. So why isn't it doing that? Oh, it's because it's only doing it if it is a reference. It's the same problem I had down here. Because I'm not setting the stack one to, okay. This is problem. This is root of problem here. Is that we weren't setting it at all. Linking error. Oh wait. No, it's just that this isn't resetting. So stop that, rerun that. So 0, 1, 2, 3. There we go. This check function name. There we go. Create struct. This is the correct function. And failure. Devastating, crippling failure. So I'm gonna put a breakpoint there. It never gets called. Interesting. Oh wait, never mind. It never gets called for the first 3 functions. Okay, we're good. We're good. We're still good. So, rerun. 0, 1, 2. Okay. So I'm dumb. If this is a reference, or it is a struct, or it is both. That's the actual thing I want to do happen there. 1, 2. There we go. So this one is ref should be false. Come on. Overlay thing that works half the time. You gonna work? It is not going to work. Context info. Because yeah, reference is false, but this is a struct, so behind the scenes it is treated as a pointer, which means this should now be set as a stack reference. There we go. This should work now. So value now has a flag set that sets it as a stack, and then we actually do the jank copy constructor and all that. We should have another one of these. Yep. This looks like a different error. From nowhere. Access violation writing location. Okay, we're going to access violation reading or access violation writing a null pointer. So where am I writing a null pointer? Because all this code worked before. Before I started doing refactors, okay. So this failed. But for some reason, okay. Hello, how's it going? Ooh, nice. So it's actually working this time. Because, yeah, I started the stream, like, around 3 hours ago. And I tried to start the TikTok stream at the same time. But, like, my phone, it had a pop-up about an internet error. But then I'm like, you know, it looks like it's still streaming. I'll just leave it there. So, like, I streamed for, like, an hour and a half before getting up and looking at it, and then it was like, oh yeah, I haven't been streaming on TikTok for an hour and a half because of an internet error. So it is good to hear that that is still working, and just kind of, it is surviving. But yeah, now you can hear the synthwave. It should be a much better listening experience. So let's see. Okay, I do have registered. It is. Yeah, it's always fun to come across another coder's page. So most of the time you don't. It's like, it's rare because like TikTok knows you're a coder, but there's not enough coding content to consistently push a ton of it. At least that's been my experience so far. Well, with that said, you ready to debug some raw assembly code? Because it looks like that's what we might need to do for this one. So, yep, it is this one. Though strangely enough, he's not complaining about this one. Though it might be. That one might be causing problems. Yeah. Alright. Raw assembly. Let's see, what's the shortcut for that one again? Alt-Shift F7. Oh, come on. Let's see, how long? Over 10 years at this point. Very long time. Oh wait, that's not when I call the function. This is the line I call the function. See, I'm after 10 years, you don't stop making stupid mistakes. You instantly realize you made a stupid mistake, and then you feel even more dumb. All right, so quad. So I think that's return type. So I think, yeah, this looks like it. So this is the function. So as the title says, we are coding our own coding language, and it's actually just-in-time compiled. So it's like an embeddable coding language. So it's something it's meant to be put inside another project. So think of something like a game engine, because, well, that's what I'm using it for. Or, well, game engines usually do it in a different way. I'm making a weird game engine, but basically the script can be compiled at the runtime of the game, and then we compile it into raw assembly code. So these are the actual instructions that the CPU is carrying out in x86 assembly. This is a weird notation, though. I'm not quite sure which notation this is, because I'm more used to the Intel one. But basically, it's converting. Dang it! It's not actually showing it. 1 second. There we go. Now it's showing it. So the one that we are debugging right now is this one. This create struct one, which all it does is create a struct. We then create a reference to the structs. It's like a kind of like a pointer sort of deal. Move a bunch of constants into there, and that's what these are. This won't actually show up in the assembly. It will be like a constant. Yeah. Smooth bytes with longs. I know, it's not really lining up for me though, so I'm not really having a hard time telling what's going on. And I forgot to fix that. Dang it. I fixed the formatting on this over here, but not over there. Well, we'll just start kind of stepping through. Oh, wait. I am starting to recognize stuff. Okay. So, right here. So first we have a subtract Q48. So I think this, well, it's not 48, it's 48 in hexadecimal, and unfortunately I've not figured out how to read hexadecimal and convert it, so like, I'm too lazy to look up a calculator. So 16 times 8 plus 4. Okay, so 132. Actually, no, it'd be 8, wouldn't it? No, it would be 16. And the 16 would be times 4. And yeah. Times 4 plus 8. That is much more reasonable. So that's the size of the struct we're allocating to the stack. Because I think RSP is x86. That is the stack pointer. x86 stack per register. Yep. So SP or RSP or ESP, whatever. So this is what's holding the current stack pointer. So we subtract from that to increase the size of the stacked, increase the size of the stack because the stack actually moves downward through memory. Then we eliminate. So this is where we actually this is the equivalent of, so these two are the equivalent of this instruction here. This instruction here, I don't have it actually writing out, but it's moving a 0 into the reference. So initialize that register to 0, and then move a bunch of stuff into that register. Yay. RDX AL. What's in AL? Anyway, I'm just gonna kind of ignore between the lines, kind of. Because these numbers are here, those are lining up with the actual offsets of the pointers. Okay, so this is when, so I think I allocate or not allocate, I set a Boolean first, and that's why this is just AL, because that's a smaller register. And then RCX is where the constants are, I think. No, RC. I just realized something. I forgot that in this notation it's from left to right, where I'm used to the right to left one. Okay. So we're moving that into, so RDX is like constants. So then we're moving RDX into EAX into, okay, so this is where the constants are stored. And then this is where we actually move it. No, this is where we actually move it into the struct. So that's all looking fine. Oh, that's what causes the... Huh. So that's what's causing the error. RCX. Move 0 into RCX. Move back. Okay, I see the problem now. It is glaringly obvious. The problem... I didn't need to look at the assembly for this. I have it in my instructions right here. But when I create it, so I create the new struct, and this is when it gets allocated on the stack and everything, right? And then we create a reference, and that reference gets initialized to 0. That's what this command is doing. And then we set that to reference output, right? That's not showing up anywhere over here. We just go straight into these 3 commands, which is this. I think. Oh! I see what's happening now. Yep. I know exactly what's going on here. So... it's treating this as one of these, so it's assuming that we allocated space on the stack here and we're copying it in. This is a problem with my assignment nodes. So dual arg return cast assign, there we go. So reference, if this is a stack ref or an external reference, okay. So that, yep, this is problem. I need a way to tell if it has been initialized. So we're just going to go real fast through here, and we're going to create a new flag, which is just we'll put it at the bottom. And we can also use this for different things. Like in the future, just we can yell at people if they didn't set a variable and stuff like that. Initialized. And now, whenever we create a new register, because like the first time you set a reference, I wanted to actually just copy the pointer over, but every point from then on, it gets treated like a regular struct, basically. So in that sense, so the first assignment to a reference should copy the pointer, and then anytime after that, it just copies all the variables over. So to do this, we'll go new register, value, actually initialized isn't getting set, so we don't need to worry about that. For constant, I'll worry about that in the constants node, value nodes. Constant, where is constant? There's constant. So when we generate the bytecode for this, value, flags, and we will set the AOT value and we'll set this as initialized, like that. And then in value, here, actually do want to set this to be initialized because we automatically initialize these to 0 because I want to be able to, you know, check if they've been initialized or not. Actually at runtime. So we also want to set this one to be initialized as well. Actually, no, we don't want to set that to be initialized because it hasn't actually been set to a value. And then we'll actually set so we want to invisit function as well, set them to be initialized. Arguments, value, and value, flags, just like that, because all the arguments are initialized, and then, or at least they should be. One more place. Operations, assignment nodes. After this is done, we want to set the L value to initialize because it has been set. And L value is initialized. So if both of these are a reference and the left value has been initialized, then we will set that. All right. Oh, it just worked. Kind of. The values are still wrong. But no compiler error. exception 03 encountered at address whatever. Can't delete an incomplete type. Oh, is it because I'm storing them here? And no, I import the header. This is in the default delete of compiler context. Okay. That's super weird. And we also include AOT node, which has the AOT value in it, which means linking error. Oh, it's this again. It's not an incomplete type, though. It's a very complete type. Unique pointer Brane script AOT value. That is super weird. I think what I'm gonna do is just reset the cache, reload the project, rebuild the entire thing. The problem isn't that it isn't building, which, like, it shouldn't build at all. Can't delete an incomplete type. This is the compiler context, which is literally when we delete this vector, it freaks out and thinks the AOT value is a non-existent, well, an incomplete type. Oh wait, I'm being dumb. Can't delete incomplete type. This is a static assert. This would have fired if it was a compile error. The actual thing is on the regular delete, so okay. Not weird compiler error, I am overthinking this. Problem is with the compiler, current context pointer. Here are all the values. Maybe... Set function, this is when we reset all of these. We reset register index and memory indexes, which wouldn't have an effect on the values. But we should probably still clear this between each function compilation. And then, just so that we get the error earlier as well, let's go over here. And then we actually compile. Let's see, IR script. Null pointer. Oh, pointer. Ret equals return script. Return ret. And then we're actually going to set to null pointer. That way we just clear up all the memory. So now we get the problem here. So it is whenever we clear this. Oh, okay. It's right there. Found it by accident. We were accidentally adding this to the list twice, so the pointer was being deallocated twice. There we go. Oh, that was that was also the problem with the objects. Look at that. Programming language working. And much easier to deal with now that values are actually by reference instead of by value through the node system, meaning I can actually change them and stuff. So look at that. All tests are running. See, I remember there being one of these that wasn't working before for some reason. Was it this right here? It might have been that right there that just wasn't working before. But yeah, I don't know. Anyway, I think that's probably where I'm going to end the stream, with it actually working. Yeah, well, stay tuned. I should be releasing a video about this later. We have it all filmed. It's going to look much better. We bought like a really nice camera for it, but it's going to be updates that are now out of date because, you know, I've still been working on this for the past week where we've still been editing it. But yeah, with that, I think I'm going to end the stream. Farewell.